Alright, I'm going to give you guys a couple more examples on elimination. So the first one I'm going to go over is 2x minus y equals 6 and 3x plus 4y equals negative 2. In an ideal situation, you would have the same coefficients in front of x or y and then also having opposite sides. So we could just combine the two equations together and cancel out either the x's or the y's. In this case, we don't. So what we need to do is actually scale one of my original equations. So the reason I just put parentheses around the first one is I see that there's a negative sign here and there's a positive sign in the second one. I can take this first equation and multiply it by 4. So that way the y's will be the same, and when I add them together they'll cancel out. So I'm going to multiply each term in my first equation by 4. So I'm going to get 8x minus 4y equals 24. I'm going to rewrite the next equation right underneath it. And what happens is now I see that if I add these two equations together, I'm going to end up getting 11x, y's cancel out, equals 22. Now I'm solving for x, so I'm dividing each side by 11 to get x equals 2. Okay. Now my next step is to plug in this x value and find y. So I'm going to take my original first equation, rewrite this down. Now I could have used the scaled one, the original one, or one of the two original ones. I just chose to use the first equation that they gave me. So I'm going to plug in my value of x, and then I've got 2 times 2, which is 4. 4 minus y equals 6. I'm going to subtract 4 from each side. I'm going to get negative y equals 2, remembering to carry down that subtraction symbol. I'm going to divide by negative 1, because y is not by itself. I want y to be positive. So my y in this case is negative 2. My x is just 2. So the solution is 2, negative 2. Okay, so this is called elimination using multiplication. So I've got one more for us to try together. So here we've got x plus 5y equals 4 and 3x minus 7y equals negative 10. Well, in this case, I can do a couple things, and I'm going to complete this problem this way. I'm going to take the first equation and I'm going to multiply that by 7 because I want to make the y's the same. So I want to have the same number in front of y, and I notice that they have opposite signs, so I can just add them. So I'm going to multiply the bottom one by 5. So I'm going to get 7x plus 35y equals 28. And then on the bottom is going to be 15x minus 35y equals negative 50. Okay. I'm going to add these together. So 7x plus 15x is 22x equals, well, 28 minus 50. Okay, so that's going to give me 22, negative 22. So I'm going to divide each side by 22. And I've got x equals negative 1. I'm going to plug my negative 1 in for my x and then solve for y. And I feel like I've already done this problem before, and I probably have, in the many times that I've done this. So I'm solving for y, so I got 5y equals 5. Divide by 5 on each side. So in this case I got y equals 1. So you've got negative 1, comma 1. Now I could have done this problem a different way. I could have just multiplied the top equation by 3 and then subtracted the 2, but I just wanted to show you that sometimes you're going to have to do this when number 1 was just multiplying the top by a number, so that way you can cancel out and combine those two equations to get y out of the picture and to solve for x. Or you're going to have to go through and say, alright, I'm going to have to multiply top and bottom by different numbers to find my solution. Right? So this concludes this particular example. Right? And we'll talk more when we see each other next.